Welcome. This question says a car sounds a horn at 261 Hertz. It approaches a stationary observer at 45 meters per second. The speed of sound in air on this particular day is 343 meters per second. So what frequency is heard by the observer? So if we picture this, we have a car, and let's put in its frequency 261 Hertz, and it's traveling towards a stationary observer at 45 meters per second. This would be V source, and then somewhere on here there's an observer, and the observer is stationary, so V observer is equal to 0 meters per second. And as the sound approaches, the source approaches, and so we're going to say, what frequency does this person hear? And the governing equation is given, well, let's just go a little bit slower. So our V source is equal to 45 meters per second. And our V observer, because it's stationary, is equal to 0 meters per second. And our frequency of our source is equal to 261 Hertz. And we would, and the velocity of sound on this particular day is 343 Hertz. Not 343 Hertz, that's for sure. 343 meters per second. So, and it wants to know what the frequency observed is. So there is a governing equation, and the governing equation is that the frequency observed is equal to the frequency of the source modified by a ratio, which is the velocity of sound in air added to the velocity of the observer divided by the velocity of sound in air minus the velocity of the source. So let's put our numbers in. So the full frequency of the observer is equal to 261, and then we're going to modify it by this bit. So we have 343 is our speed of sound in air, and we've got to add on to this the velocity of the observer. In this case it's 0. And then we're dividing it by 343, which is the velocity of the observer, which is the velocity of sound in air. And we're going to subtract from this the velocity of the source. And here's the rule. If either of these things is moving, if they're moving towards the other object, then they're positive, and if they're moving away, they're negative. So this would be, because it's moving towards a positive 45. So this is the frequency of the observer is equal to 261 times 343 over, and this is going to be 298. So when I put this into my calculator, I see I get 300.41 Hertz, which is basically 300 Hertz. So it's a catch-all equation. This is a catch-all equation. You can learn 4 versions of it. You can learn one for where the observer's moving but the source is stationary, one for where the observer's stationary but the source is moving, and then one where they're moving towards, one where they're moving away. But this is just a catch-all equation, and the only thing you got to be careful about is what sign do you give to these values of V observer and V source. And if they're approaching, you call them positive, and if they're receding, you call them negative. So there we have it.